All right, welcome back into our next section. We're going to be breaking this down into little subsections as well, but let's start off with Windows hacking. All right, now when we get into the Windows hacking side of things and so forth, we need to, of course, know about the OSI model. Now, when it comes to the OSI model, as we've seen before, the data link layer is layer 2, and this is where a lot of your attacks are going to happen. I'm going to mention a few different attacks, but a lot of them are going to be requiring the use of ARP cache poisoning and such. And we'll take a peek into some of those examples that I'll be giving you here in just a moment. But keep in mind, this would be a great indication for ARP cache poisoning, for man-in-the-middle type of attacks and the such. And let's take a peek into some other things we can find. So here are the different types of attacks that we're going to be discussing. And the first one here is called the MAC attacks. Now the MAC attacks has to do with your MAC addresses, as in your physical address of your network card, right? Now the MAC attacks specifically go towards, a lot of times, your switches and such. So a switch, keep in mind, has to do with controlling the traffic that goes on the network, right? With a hub environment, as we discussed before, is everything crashes together, right? We have what's called the carrier sense multiple access collision detection, right? Data basically gets put on the wire, and next thing you know, collides with some other data, and then has to reset and wait at a random interval and send the information again, and then hope that it doesn't collide again. If it does, guess what? It just goes through that process over and over again, right? Especially if it's using TCP. Now, if it's doing UDP, it's just going to send it out and it's just going to get lost, you know. But with the use of switches, we were now able to take something like our big broadcast environment, and we're able to narrow down that broadcast and also just allow the data to go through what we call the carrier sense multiple access collision avoidance, which is also true in the wireless world, which basically avoids collisions from happening in the first place. So the switch will basically check the wire and say, hey, no, nothing's going on, we'll send it out. And it knows what port it goes out of and what port it comes in at and so forth. Now what we can do is we can compromise that switch. Now switch has that content addressable memory table, the CAM table, which can be overwhelmed and overflooded, more or less. And basically it can hold only so many entries, which I think the standard ones are like 8,000 entries or something like that. Okay, so what we can do, however, is we can use a tool called MAC-of, which allows us to actually bombard that switch with literally like 131,000 entries per minute. These would be basically MAC to IP pairings that it will send to the switch. Now, what should then happen is, hopefully, is that the switch will fall over into hub mode, and it will continue to provide data through the network and such, right? However, it would be like a hub, which basically means that now this active sniffing environment that we had prior with just the switch is now becoming could be more of a passive type of sniffing now, because we can see the entire network now, where before we only saw what we were connected to and such, right? So there's definitely some cool things going on there. And again, I mentioned MAC-of tool that will assist us in that process and so forth. Now, we can also, of course, defend against these types of attacks just by enabling port security on the switch. That's really just enable the port security on a switch will do the job, and so forth. So remember, if we get flooded, right, the switch will basically fall over into hub mode, and then cause the attacker to allow to see the entire network and so forth, right? So the switch acts like a hub by broadcasting packets on all the machines on the network. And again, that's a really awesome little thing, and the tool that we use for that is called MAC-of. It's really cool. And a lot of your switches, of course, nowadays are going to be protected against this type of attack. However, just know that it is definitely still possible. Best thing to do is try it out against your own switches and see what you got going there. Okay, now the second type of attack here that we're mentioning is the DHCP attacks. This is your Dynamic Host Configuration Protocol Servers attacks. Now this has to do with, of course, you're handing out of your IP addresses to the clients. As they boot up to the network, they'll go out there and say, hey, is there a DHCP server available? And the DHCP server says, yep, I'm available. And then basically go through a little process that then hands out a valid IP address from its scope that it can then allow that client to get onto the network and so forth, right? Now, what happens is we can do different things here. Now, we can, do what we'll call a DHCP starvation attack. And just as it sounds, what we're trying to do is we're trying to starve out the IP addresses that the DHCP server has in a given scope. And we do this by bombarding it, again, using different tools. A particular tool here that comes to mind is one called Ucernia, which does actually a pretty good job on that. And again, specifically works on getting rid of those IP addresses available on the DHCP server and making those unavailable because it's using those all up, which is sort of like a denial of service attack because it basically prevents legitimate users from actually gaining and grabbing a valid IP address. Now, the other thing we can do when it comes to DHCP attacks is we can put up a rogue DHCP server. And this is basically where we put up our own DHCP server on the network in hopes that whenever the client actually boots up, that we give it the IP address information, the DNS server information, and so forth. And with that, again, we then have more control over what data goes through the network and so forth with that. And again, with a lot of these types of attacks, the whole thing we're trying to do, again, is to take over control, right? Take control over the network and where the data is traveling and so forth. Now, what we could do with regards to some of this is we can actually go out there and set up our DHCP servers and so forth to not allow those types of changes. Okay, the next thing on the list, which is also pretty popular, is the ARP attacks. Now, the ARP attacks has to, of course, do with man-in-the-middle attacks. Those are great, right? So once we have ARP cache poisoning going on, boom, we're actually able to do man-in-the-middle type of attacks and so forth. And that's always great because then we can actually capture all the traffic that goes between the target and the server, wherever it's going, and we're able to capture all that data because it's going through us instead of going directly to the server or the web server or whatnot on there. Now, obviously, remember that's going to be at the layer 2 where we have the initial compromise, and then with that we can also then do the DNS poisoning, where we're doing DNS cache poisoning and such along with that. And that then allows us to actually go out there and redirect the traffic of the users so we control where they go. So when they go to google.com, we can redirect them to any other website that we want. Now, another term that may come to play when it comes to these man-in-the-middle attacks and so forth is also known as IP spoofing. And so forth, which kind of leads us right into our next attack. Now, before we get into that, just know that whenever we're trying to take over a network, the best thing to do with the ARP cache poisoning attacks is to actually ARP spoof the default gateway, because that's where all of your clients will go through generally to get to the internet, and voila, with that you can control pretty much every device out there and so forth with that. It's a pretty sweet deal. All right, now also you can also prevent ARP poisoning attacks and such by enabling what we call the DHCP snooping binding table and enabling dynamic ARP inspection to make sure that it actually sees those changes if they're made. Or of course use static entries as well, which won't allow then those changes to be made and so forth. Now, another thing we can also do as we mentioned with some of the other attacks is we can of course do port security and so forth on your switches as well. Right? Remember we talked about the initial man-in-the-middle using the ARP cache poisoning. We talked about, when it comes to other things that a lot of times on your switches, let's say, or on your routers that get ARP cache poison, you can actually prevent those from happening, as I mentioned, through what's called the IP DHCP snooping, or the enabling the snooping binding table and so forth on your routers to help protect against those types of attacks and so forth along with that. All right, so when it comes to those spoofing attacks, again, they allow us to just do that. We're able to spoof not just IP addresses and so forth, but we can spoof the MACs, right? We can pretty much pretend that we're somebody else on the network and so forth, right? And there's other general attacks, of course, that you can use that will go against the DNS servers, DHCP servers, as we already mentioned, domain controllers and the such, and it allows us, again, to do a lot of cool extra things that we can get into. Now, one more way that I can think of is to defend against those types of attacks is using something called ARP wall system to block your ARP spoofing attacks. You can also use private VLANs, and maybe even, as I mentioned already, use static ARP entries on the servers, on your routers, and on your workstations and so forth along with that to assist with that whole process as well. Now keep in mind too, when it comes to other general attacks, these will basically be things like SYN flood attacks and using a Smurf attack and so forth, which we'll talk about later in a little greater detail as well. But this is basically where we're trying to flood the network with certain packets, whether it be UDP packets using the Fraggle attack, using ICMP packets, using Smurf in that sense, or using just the SYN flood that allows us to go out there and flood the network with SYN packets, which will then allow us again, to possibly do some type of denial service against whichever device that we want. One final thing here too is when it comes to detecting IP spoofing, what you can do here is you look at the sending packets that claimed the host will result in a reply. So one final thing here when it comes down to how do we detect IP spoofing and such, keep in mind what we can do is we can actually send a packet to the claimed host that's going to give us a reply. Now, if the time to live value in the reply is not the same as the packet being checked, then you know that it is a spoof packet. Simple as pie, right? All right, let's take a peek at some of the passwords and so forth, attacks that we can use. And here, obviously, we get into things like social engineering, right? This is where we can call things in possibly over the phone. We can show up, do some shoulder surfing. Dumpster diving would also be part of that. Right, we have digital attacks, and the digital attacks will go to everything from keystroke loggers to password cracking using tools like Offcrack, John the Ripper, things of that nature. Looking at dictionary and brute force attacks, and what we call the rainbow tables, which is our pre-computed hash values that are stored in the database that just gets checked and verified. And with that, we have the ability to quickly, very quickly, get weak passwords found out. So when it comes to the keystroke loggers, again here keystroke loggers are basically one way of obtaining the username and passwords as well as other information with that. Right now we can get screenshots and all kinds of other things with that. They can also be software based and also hardware. So mainly here when we're looking at some of these, you have SpyBuddy 2013 for instance, Keylogger tool review at keylogger.org. You have SpyTech. Go to spytech-web.com. Spectre 360 Recon and Keystroke Spy, just to name a few of the different software keyloggers and so forth that we can have. Now some of these will also sell some of the hardware side, which will basically get into your PS2s, your USBs, your Bluetooth and wireless and such as well. Pretty cool stuff when it comes down to grabbing things like your keystrokes and of course screenshots and all kinds of good stuff there. A lot of cool things again, and doing it where it's not detected by our antivirus systems and so forth. Now, another thing we can do, of course, we can do some password guessing, and password guessing involves actually attempting to log on to the target. Hackers here can write a script, or they can use an automated tool to enter credentials to various servers such as FTP, Telnet, terminal servers, and then mapping it to the $, which is the admin share, hidden share that is going to be on all of your Windows machines and such. Now TS Grinder is also an automated password guessing tool that attempts to log in to the administrator account on your terminal servers. There's also other tools that we can use like Kenable, Obi-Wan, Brutus, and the also popular THC Hydra. Okay, since we're talking about passwords, let's take a peek at some of the weaknesses that we have, what's called the LM and TLM hashes, LAN manager hash and such. Right, so password cracking involves obtaining the password hash and performing offline attacks against it. Both the SAM database and the Active Directory database here store the user's passwords in two formats by default. One is called the landman hash. Now the thing with the landman hash is it has a maximum length of 14 characters and it is limited to uppercase only. And we have what's called the NT hash, which has a maximum of 127 characters and it could be in mixed case. Now before encrypting the password to create the landman hash, The 14-character password string is split and each half is encrypted separately. The landman version of the password is obviously going to be easier to crack, as we'll see here in a moment as well. Here we see a sample of Cain-enable showing us the local password hashes that we can see here. So when it comes down to the LM hash encryption side, if there's anything else regarding that, regarding having less than 14 characters, it will actually pad with null characters to make it up to 14. They are then converted to uppercase and then separated into 2-character strings. So here we have Dallas 1, 2. So Dallas 1 would be the first 7. 2 would be the second part of the 7. And then, of course, it nulls out the rest of the characters to your 14 characters. Right? It then goes out and, of course, encrypts it, puts it out, and voila, we have now our LM hash file. Now, it takes those both separately, concatenates them together, and then with that, we have a very long string value of our LM hash password and so forth. Now, we'll get to see a tool here in just a moment too that allows us to actually see some of that in action. Another thing though, because the SAM database, your security accounts manager, that has basically all of your usernames and hashed passwords on a Windows system. Now, it was since NT 4.0 Service Pack 3, Microsoft had introduced what's called the sys key, which basically allows 128-bit encryption to the SAM database. Now, one of the favorite methods of attack in the past was just to obtain the copy of the SAM, then utilize a program like lawful and crack the passwords with it. Now, with syskey, we have to crack it first. Now, what's nice about it is that there are tools out there that will allow us to actually crack the syskey. The tool is called bkhive. It can extract the boot key from the system file. The boot key can then decrypt the SAM database. And Cain can also decrypt the SAM as long as it has admin privileges. So you can use the syskey.exe utility to additionally secure the SAM database by moving the SAM database encryption key off of the Windows-based computers. So when it comes to some of the cracking techniques, again here we have guessing, which we've mentioned. You go out there, you take a guess. We have dictionary attacks, and this is basically where we go in and we point it to a file. And that file will have whatever in it, and it will check basically against that. And if there's a match, it would have then cracked. Now we have what's called brute forcing, which the brute force attack is going to be a little different. With brute forcing, we're basically trying every single combination up to however many letters that we've specified. So if we say this is a 8-character password, it's going to brute force that and try every single combination to the 8 characters that we specified. And depending on if it's all lowercase, upper lowercase numbers, or upper lowercase numbers and symbols, whatever the case, obviously the more complex it gets, the longer it will take. It will generally take a password of 22 characters to be cracked in 5 minutes if it's part of a dictionary attack, for instance. With brute force, it may take a little longer than that, obviously. But just know, if we have the right type of attack that we're using, and even a long password like a 22-character password could be broken in 5 minutes if it's within the dictionary file and so forth, right? So keep that in mind as you're out there. The longest would take, but guaranteed, it's going to be the brute force attack. Now, the shortest way of doing things is, as in the quickest way, is going to be using pre-computation. And another term for that is called rainbow tables. And it basically involves hashing each word into a dictionary or any search space of candidates' passwords and storing it in a plain text to ciphertext pairs in a way that enables lookup of the ciphertext field. This way, when a new encrypted password is obtained, the password recovery is instantaneous. And there are certain tools out there that will allow you to do that. So what we're going to show you here is one called OPHCrack, OPH crack. And it does actually a really good job on finding weak passwords, especially when it comes to the SAM database and so forth. So we'll take a peek at that and see what you think, but just know that OPHCrack is definitely one of those favorable tools when it comes to rainbow tables and so forth.